All right, welcome. Think of this as a special tour through a museum of grand deceptions. Today, we're going to look at some of history's most incredible illusions, peek behind the curtain to see how they worked, and then we'll step into the final exhibit, the one that's being built all around us right now. So, let's get started. What if the most complex, the most convincing illusion of all time isn't in some dusty history book? What if it's sitting on your desk, in your phone, captivating billions of us at this very moment? That's the big question we're tackling, and the current AI boom is our main attraction.
To really understand the illusion of today, we have to meet its most famous ancestor. This is the Mechanical Turk. For the better part of a century, this amazing automaton toured the world, just blowing people's minds. They would open up its cabinet, show off this incredibly complex mess of gears and clockwork, and convince everyone, from Napoleon to Ben Franklin, that they were watching a machine think. But of course, it was all a brilliant hoax. Tucked away inside was a human chess master pulling all the strings. The Turk is our guide here. It's the perfect reminder that when a performance is good enough, we are so willing to believe in the magic of a thinking machine.
Okay, so before we crack open the cabinet on today's AI, we need to look at the blueprint for any great illusion, especially one this big. We're talking about a financial bubble. This is the engine, the fuel that powers the hype and makes the trick so utterly believable.
An economist named Hyman Minsky famously mapped out these stages, but honestly, you can just think about it like a kid's birthday party. First, you've got displacement. Some new, shiny balloon, let's call it AI, catches everyone's eye. Then comes the boom, which is really just driven by pure FOMO, fear of missing out. That builds into total euphoria, where all logic gets tossed out the window and everyone starts chanting, "This time is different." But then, the insiders, the smart money, they start profit-taking, quietly selling. And finally, panic. One balloon pops, and the whole thing comes crashing down. We've seen this play out time and time again.
All right, let's move on to the main event. It is time to do the one thing the creators of the Mechanical Turk were terrified of. We are going to open the cabinet of modern AI and see how this magic trick actually works.
First off, we need to get our terms straight, because this is super important. The big science fiction dream of AI research has a name. It's called Strong AI, or AGI, Artificial General Intelligence. This is your HAL 9000 from 2001, your data from Star Trek. A machine with real consciousness, real self-awareness. And here's the absolute key thing you need to know. This kind of AI does not exist. It is, for now, purely theoretical.
So what do we have? We have weak AI, sometimes called narrow AI. Now these systems are unbelievably powerful, but they're tools designed to do very specific tasks. They simulate intelligent behavior, but they don't have any actual consciousness or understanding. And let me be really clear here. This isn't just some AI systems. This is all of them, from the Siri on your phone to the most advanced models like ChatGPT. This table really just lays it all out, and you can see, this isn't a difference in power or degree, it's a fundamental difference in kind. Weak AI is about doing a task. Strong AI is about being a conscious mind. The entire illusion we're talking about today is built on confusing one for the other.
So, if these systems aren't thinking, what are they actually doing? Well, researchers have this brilliant metaphor for it. They call it a stochastic parrot. See, large language models are trained on an insane amount of text from the internet. They learn to mimic human language simply by calculating the statistical probability of which word is most likely to come next in a sentence. It's like a parrot that can repeat back incredibly complex phrases flawlessly. The performance is perfect, but there is zero understanding of what any of those words actually mean.
And this isn't some new idea. Way back in 1980, a philosopher named John Searle came up with his really powerful thought experiment to get at this exact point. It's called the Chinese room argument.
Okay, let's walk through it together. I want you to imagine you're locked in a room. You don't speak a single word of Chinese, but you have this massive rule book, all in English. Now someone starts sliding slips of paper with Chinese characters on them under the door. These are questions. You use your rulebook to look up the shapes of those characters and find the corresponding correct characters to send back out. From the outside, anyone watching would swear you're a fluent Chinese speaker. You're giving perfect answers.
But here it is. Here's the critical question. Does the person inside that room, you, actually understand a single word of Chinese? Of course not. Not one bit. You've just gotten really good at following a set of rules. And that is Searle's entire point in a nutshell. Here's how to think about it. Syntax is the grammar, the rules for arranging words correctly. Semantics is the actual meaning behind those words.
An AI, just like you in that room, is an absolute master of syntax, but it has no access whatsoever to semantics, and no amount of perfect grammar can ever create real understanding.
So, if it's all just a sophisticated trick, right? A stochastic parrot in a digital Chinese room, then why is it so powerful? Why are we as humans so eager to believe in it? Well, the answer lies in our own psychology. There's a cognitive bias called anthropomorphism. Basically, our brains are hardwired to see human-like intentions everywhere. We see faces in clouds, we talk to our pets like they're people. So when a machine talks to us in perfectly fluent, human-like language, our first instinct is to assume there's a human-like mind behind it. It's a mental shortcut, kind of like a glitch in our own software. And it's a glitch that modern AI is being designed, very deliberately, to exploit. And this leads to some very real dangers. Misplaced trust is a huge one. Studies have shown that people will believe factually wrong answers if the AI just presents them in a confident, persuasive way. There's a real risk of emotional exploitation as people start forming bonds with systems that literally cannot feel anything back. And maybe the scariest part? Even the people building these things are starting to admit they don't fully understand or control their own creations. So let's head to our final exhibit. This is where we put the silicon imposter right next to the carbon-based original. And this is where the whole illusion really just breaks down completely.
I mean, the differences here aren't just small, they are profound. An LLM learns from a static, disembodied pile of text from the internet. We learn by living, by interacting with the physical world through all our senses. An LLM's computation is cold, statistical. Our thinking, our reasoning, our memory, it's all completely intertwined with emotion. And that gets us back to the most important point. AI is a master of syntax, the rules and patterns of language. But human thought is built on semantics, the actual meaning, the intent, the feeling behind the words.
So the takeaway from all this is really clear. These systems are not baby minds. They are not our new thinking colleagues. They are incredibly powerful pattern matching tools. And the second we forget that is the second the illusion has won.
And that brings us right back to where we started, doesn't it? The Mechanical Turk was a beautiful, masterfully built illusion. It worked because it used a hidden mechanism and preyed on our deep-seated desire to believe that a machine could think. Today, we're surrounded by a far more sophisticated, far more seductive version of that exact same performance. And so the question it leaves us with is maybe the most important one of our time. Is this time really different?